Good day, everyone. I am Mr. Garth Reed, Student Ambassador in the University of Technology Jamaica and Mathematics Teacher in Training in the School of Mathematics and Statistics. Today we'll be looking at a CSEC additional mathematics question in section 2 of the syllabus, which is vectors, trigonometry, and coordinate geometry. All right, and we're focusing on trigonometric identities. Okay, so here we have a question which says prove the identity tan theta minus 1 over cos theta all squared is the same as negative sine theta minus 1 over sine theta plus 1. All right, so that is what we have, and we're going to prove this identity. Now, just to let you recall some of the trigonometric identities, all right, these are the identities that I will be using in this video. So recall that the tan theta is equivalent to sine theta over cos theta, and the cos squared theta plus sine squared theta is equivalent to 1. And if we transpose that identity, all right, if we rearrange some terms, it implies that cos squared theta is equivalent to 1 minus sine squared theta. Okay, let us now get into the question. So we have our solution. Now the left-hand side of the identity, all right, that is the tan theta minus 1 divided by the cos theta, all right, 1 divided by the cos of theta, and we're squaring that expression, all right, squaring that. Okay, good. So this is now equivalent to, we know that tan theta is equivalent to sine theta divided by cos theta. So I'm going to do that identity here. All right, so replace tan theta with the sine of theta, all right, divided by the cos of theta, all right, divided by the cos of theta, minus 1 divided by the cos of theta. And remember now that we have to square that expression. All right, so all squared. Good. Now, if you look inside the brackets for these two fractions, you realize that cos theta is the denominators for both. All right, and whenever that is the case for fractions, we just simply add the numerators. All right, so let me just scroll down so we can get some space. So I can now say that this is equivalent to sine theta minus 1. All right, so adding the numerators, we get sine theta minus 1, and we are dividing that by cos theta. All right, and remember now that we have to square this. Okay, good. That is what we have. Now recall, all right, I'll be using our laws of indices here. Recall, if you're squaring a fraction, so let's say you have a divided by b, and you're squaring that, all right? That is going to be equal to the square of the numerator, so a squared, divided by the square of the denominator, which is b squared, all right? So what I now have is that this is equivalent to the square of the numerator, which is sine theta minus 1, all squared, all right? And we are dividing that by the square of the denominator, which is cos squared theta, all right? Now, just to refresh your memory, and if you have the cosine of theta raised to the power of n, all right, that is equal to cos to the power n of theta, all right? Once that number n is not -1, all right, this is always going to be true, all right? Those are always going to be true. Good. So we have the cos of theta all squared, which we know is the same as cos squared theta, all right? Good. So once you see the power on the inside, you know that the expression is being raised to that power. Okay, let us now continue. So this is now equivalent to, all right. So we have sine theta minus 1 all squared. So sine theta minus 1 all squared. All right. Now in the denominator, I had stated that using cos squared theta is equivalent to 1 minus sine squared theta. All right? So that is the term that I'll be having in my denominator. So we'll be having 1 minus sine squared theta. Okay. Now, if you look carefully in the denominator, we have 1 minus sine squared theta, and 1 minus sine squared theta can be factorized, all right? Because if you recall the difference of squares rule, all right, a squared minus b squared is equal to a minus b multiplied by a plus b, right? That is the factored form of the difference of squares. So this is now equivalent to sine theta minus 1 all squared, all right? And we are going to divide that now by the factored form of 1 minus sine squared theta. So when we factorize that expression, we will get 1 minus sine theta multiplied by 1 plus sine theta. All right? So that is what we have. Good. Now this is equivalent to, okay, what we wanted to know is do some cancellation. All right, we want to cancel some terms. However, if you look carefully, we can't cancel any terms. All right. Now, if you look at this and say you have sine theta minus 1 all squared, and you have 1 minus sine theta in the denominator, and you cancel those out, you will be incorrect. All right, those are not the same terms, so we can't do any canceling there. Okay. However, what we can do is to just manipulate the term in the denominator. All right. So we have 1 minus sine theta in the denominator. All right. So we have sine theta minus 1 all squared divided by, we have 1 minus sine theta in the denominator. So what I'm going to do now with that term is to just factor out a negative 1. Okay? Factor out a negative 1 in the 1 minus sine theta term. So when I factor out the negative 1, the sine theta will turn into a positive, all right? But the 1 will change into a negative, all right? And I still have the 1 plus sine theta term in the denominator as well. Now, if you look carefully, we can now do some cancellation, all right? So I can cancel out one of the sine theta minus 1 term, all right? So this is now equivalent to, in the numerator, all right? So there's a negative 1 here. In the numerator, I now have sine theta minus 1. Okay, I have sine theta minus 1, and I'm going to divide that now. I'm going to divide that by 1 plus sine theta. All right. Now remember that there's a negative in the denominator. So what I can do is just put it to the side. Okay, just going to put it to the side. All right. And I'm just now going to rearrange the denominator. So what we have now is that this is equivalent to the negative of sine theta minus 1. I'm just going to switch around the 1 plus sine theta. So I will now have sine theta plus 1 in the denominator. All right, good. Now remember that this is now the left-hand side. All right, just go back to the question. So we have the negative of sine theta minus 1 divided by sine theta plus 1. All right, and if you go back up, you will see that is exactly what we have on the right-hand side. All right, so we have proven that the left-hand side is equivalent to the right-hand side. Okay, so this is the left-hand side, which is equivalent to the right-hand side. All right, that's what they asked us to prove. So we can now write proven. All right, we can now write proven. Good. And that is the solution to to this trigonometric identity question. All right? I am Mr. Garth Reed, student ambassador in the University of Technology Jamaica and mathematics teacher in training in the School of Mathematics and Statistics. If this video was helpful for you, please ensure to like this video, subscribe to the channel so that I can make more videos for you, all right? And also comment down below. I thank you for joining.